Hello everyone, I am Lazar and I'll be there as a tech support during the tutorial. I want to introduce you to our tutor, Mario Annau. He is managing director at Quantargo and he will hold the Shinylive, running R and Python dashboards without a separate tutorial. Enjoy.
So hi everybody, thanks for the kind introduction. I hope I could hear everything, but let me again introduce myself. I'm Mario Annau, Managing Director of Quantargo. We offer companies trainings and consulting in the data science area, mostly R and Python, but also cloud related. So in any case, if you want to approach us or need support, we're currently sitting in Vienna, but tomorrow I'm taking my flight also to Belgrade. And if you have any questions, please just approach me, just have a quick chat, and I would be happy to talk to you. So first things first. Next, I attended last I think 2 months ago or 1 month ago, the last POSIT conference. So POSIT, for all of you who don't know, is now the new brand or new company title of our studio. So they're now converting more and more towards also the entire data science area, including Python. And they're also offering more and more services and products for Python. And that's actually the new thing. So more and more RStudio or POSIT products are now also supporting Python as a first-class citizen. For example, the famous Shiny dashboard framework, which was only available to R, is now also available to Python. So with, of course, language-related differences, but you can basically do the same thing and have reactive programming also within Python. But from a technical perspective, so speaking of the last POSIT conference, I think the most important or a new technology which is coming around or is around the corner is WebAssembly, and using WebAssembly, which is already already around for a few years, but also using WebAssembly in the Shiny or in the dashboard context. So what does it mean? You can basically run, of course, your Shiny server classically. So you need to run a server somewhere in the cloud or on-prem, and then all the clients can connect to the server and and use the dashboard. So that was the classic approach, which is still around and a good one for most cases. But there's now also the possibility to run an entire Shiny dashboard, for example, also within the client. So basically the client only needs to download all of the assets or server code which is required to run the dashboard, but everything which is then run, or the entire dashboard which is usable for the users, is run entirely within the client, which has huge implications for infrastructure and makes lots of things easier. And I'm still very excited about this. It's very early. It's in a still very, very early stage. So I just don't be too excited about this. But I'm seeing it already around the corner, and I think it will be more and more important for years to come. So I hope you find this interesting, this talk, and please, if you have any questions, please just write straight away to the Q&A. I don't know if the chat is appropriate for this, but I will try to, from slide to slide, try to look at the Q&A and try to answer your questions as soon as possible. So please don't hesitate to ask anything. It's very interactive, and I hope you enjoy it. So I hope I could introduce now the new technology, Shiny, the new WebAssembly technology, and also Contargo a bit. Another little advertisement from my side is here. As you might know, I'm organizer of the Vienna R meetup. It's a meetup group which comes together and talks about R. Now also, like in the POSIT context, we are also now adding more and more Python to it to have the entire data science community around. And it's still, yeah, people are actually the same R and Python users, so it's no such a big difference. Community-wise. What I want to introduce you is to the Use R conference, which is next year. It's the biggest R conference globally. And this time, I'm very happy to announce that it will be located in Austria, in Salzburg, where Mozart was born, if you might know. And I hope if you are interested in really getting together with all the most important people from the R community, our core will be there. Lots of other companies will be there. So please come to Austria and visit Salzburg. It's a beautiful city. And of course, with very highly great data scientists and great people who will be around the conference. We'll also be organized with a few friends of mine, and I hope if some of you are interested in R and interested in the community on a deeper level, just come to Salzburg, or it will also be available online. So that's the web page. I'm just posting it into the I'm not sure if this. I'm not sure. I'm just posting it into the chat. I don't know if you get it, then, or just it's useR 2024 rproject.org. You will find it or Google it. Okay, that was just now my advertisement for now. And I would suggest that we now dive a bit deeper into the topic. So about the contents. Very basic. I will just introduce Shiny to you. For all of you who don't know Shiny, I hope that most of you do, at least for those who are joining this tech talk. And I will just dive a little deeper. So now, not only from the R perspective, so what is Shiny actually doing, but how is it actually working under the hood? So how is the client and the server communicating together? Next topic will be the deployment headaches. So I've experienced a lot of situations in my professional life, and also, but mostly in the professional life, that once you have created your amazing Shiny dashboard, you might experience a few headaches, especially in enterprise setups where you have things like IT security, login authentication, scaling, all those kinds of things, which can be very complicated and have led to, and I know a few of those projects, thankfully not lots of the projects we've developed, but I've heard of lots of other projects which failed because of exactly those things. And that's very annoying, especially for data scientists who just want to, bring who want to get shit out and want to create great products. So deployment always is a big thing in any language, also in Python. It's not only R related, but especially in enterprise setups, it can be a pain. Okay, third topic is Shinylive and WebR or Pyodite in the Python world to the rescue. So how can we use now this technology, WebAssembly? How does it work, and how can we use it to simplify the entire infrastructure case and to bring Shiny, let's say, to the next level or to another level where it will be way easier to handle and way easier to deploy and to maintain and everything. Last chapter will be just a quick demo, how you can create your own dashboards, how it works all together. So it will require a bit R knowledge, a bit JavaScript knowledge maybe, but I will just walk you through and give you the exact pointers where you can go, and how you can create your own Shiny dashboard right away today. And the last topic will be the outlook. So how do I see the future of this technology? How will it develop or not develop? And what you can do with it. So again, I'm very excited about this. I'm happy to introduce it to you, but don't get too excited to use it in your next professional project. It might be another, you will face a few other issues or headaches because it's a very new technology, but it's around the corner and maybe it's a good thing that you've already heard about it and see how things might progress in the future. Okay. Let's jump to the first topic. So about Shiny and how does it work, or what is Shiny actually? So Shiny, as I've already introduced, is a dashboard framework for mostly R, but now also Python. So it's also available for Python users. And it's been used a lot for especially data scientists who don't know JavaScript or are no web programmers, but still want to create an interactive experience for other end users who might be peers, but also could be from other departments, management, you name it. So you might be a great mathematician or have developed a great model, but this model needs to come to life and you could probably visualize the output of the model or let people play around with it. Those people don't necessarily need to be data scientists or need to have that kind of technical know-how you have, but it's a great way to just present what you've done and let people experience what it might mean to them. And the innovative part of Shiny is this whole reactive programming thing. So if you might have already developed user interfaces, like in any kind of language, you might have encountered so-called callbacks. So callbacks are whenever the button is clicked, just jump to this line of code and execute whatever that might mean. And reactive programming is just another concept. It's basically which does not require so-called callbacks. So really instructions, if clicked, then do that. But it's doing that in a kind of implicit way. What I mean by that is you kind of set dependencies for code blocks in Shiny, and those kinds of code blocks, or the framework or Shiny itself, evaluates when to execute that. So you don't have to explicitly say, whenever this and that happens, please do that. But you basically define a way to say, okay, this kind of code block is dependent on other reactive code blocks or inputs. And whenever those change, please execute it. And Shiny, or that kind of framework by itself, has to decide when to execute. So that's a cool thing, especially for programmers who want to get things done and don't want to manage all those kinds of callbacks. So that's great. There might be not, of course, it's kind of implicit, so it's not extremely, so the definition needs to be, might be missing or needs to be done by the developer. But yeah, it's a great thing and really new if you compare it also in the Python world to, oh, I'm sorry. Can't switch back for some reason. But if you compare it in Python to other frameworks like Streamlit or Dash or others, so that really in Shiny stands out, and it's also available in Python. Reactive programming, if you're an Excel user, Excel kind of is a reactive framework. If you want to compare it to that, of course, a lot of you, I know, hate Excel and oh my God, but Excel in a way execute this calculation dependent on other input cells, and Excel by itself figures out what to do and when to recalculate. You don't have to explicitly define when to recalculate. Excel by itself manages that. So that's also kind of reactive. Okay. And yeah, Shiny is highly customizable. So also compared to other frameworks, if you also develop other dashboards, of course, also in Power BI, for example, you will experience some kinds of limitations. So in Shiny, you're thankfully very flexible, of course, if you have the knowledge how to deal with it. And yeah, and there are many different Shiny dashboards. So there are a few featured demos, what you can do with it, maps and interactive graphs, and how you can basically build those kinds of dashboards together. Of course, you have also users showcases from the community. So lots of things you can do, especially maps and interactive maps and interactive graphs are very great, are really great in Shiny. There's also even games which people developed as part of those Shiny contests, which are, I think, on a yearly basis. Okay, so you can do lots of things with it, which is great. For all of you maybe who want a more hands-on introduction to that, if you have RStudio, for example, an IDE, of course, you can also use Visual Studio Code, but still RStudio is the way to go for most R-related things. Of course, for Python, I would nowadays recommend VS Code. But what you can do is you can create a new file or even a new project and create here a Shiny web app, a so-called Shiny web app. The application name is DSC23. Has to be together. I'm using here a single file and I'm using my home directory. And what you see here is exactly what I've introduced. Shiny or Shiny applications have two parts, two really separate parts, which is the UI and the server. So the UI really represents what you see in the browser. So this is the HTML part, which you see in the browser. And as you see here, it's a fluid page. It depends on Bootstrap, which is a UI framework, formerly by Twitter, now X, thanks to Elon Musk. But so this is here exactly the UI part, which has some title and some inputs, a sidebar layout. So you have a sidebar On the sidebar panel, you have a slider input to change some parameter, in this case, number of bins. And you have this main panel, which just displays a plot. So you have defined here an input and here an output, which will be generated by the server. And also, if I just execute here this part, this code, here with, I used command enter, or you can also just click the execute code button, which I don't find here, or control enter. You see here this UI object. If I just see what's in it, you see that the UI is basically only an HTML part. So this is really just the HTML, which will be displayed in the browser of the user. And what you might also see is you have these kinds of classes, range slider, which have some specific bins, IDs, I'm sorry. And those IDs are very important for Shiny to connect the client part with the server part. So as you see here, this kind of label, I'm sorry, yeah, this kind of, input ID, bins, is then connected to exactly this kind of code block, which is used to render the output plot and is sent to dist plot. So exactly, if you just compare, the bins ID here is connected here to input bins, and the output is written to dist plot. Dist plot here is then displayed as a plot. So this part here generates a plot, in this case, a histogram, and this histogram is sent back to the client. And I don't have to, it's just render plot. It's a reactive expression, which is, that's the name as it is called in Shiny. And it just discovers that, okay, in this code block, I have a reactive value. And whenever this value changes, I need to execute this entire code block. I need to generate the plot, which is then sent back to the server and displayed. So that's how it works. And this is how it is glued together, so to say. And I can now run the app. So this just now starts up the Shiny server. It now displays everything which is now defined in the UI, as defined in the UI. And now whenever I change now the number of bins in this kind of range slider, what will happen is the bins input will change. So this will change. So Shiny will know, okay, now I need to execute the entire render plot, which generates a new histogram. And this histogram replaces the dist plot, so the existing distribution plot. And since it is changed, it will also re-render the plot. So this is how, so now I'm changing the input, it changes the plot, and the plot is sent back to the client and is displayed. So this is how it works. I know this is a very simple app, but if you consider way more complex apps I've seen, this is the whole thing, how this kind of communication runs. And this also might be an annoying thing. In some cases, it might be that the entire app has a life on its own, so that the input triggers an output, triggers an input, triggers an output, and so on. So this is actually a thing you don't want. So still you want to have some more control. But just for you to know, in a way, you can still develop the behavior of the Shiny app implicitly or organically, so to say. You don't have to really explicitly define what to do when something changes. Yeah, which can be great, but of course you should only use it to some extent. And if it gets too complex, you might face other issues, of course. Okay, so this is how it works. This is a very basic Shiny app, which most of you might have already seen. Okay, now I come to maybe some annoying technical part. So this is Joe Cheng, who talks about his discovery, how he developed Shiny. I think it's great. You can watch it later if you want. I hope you also have the link to the slides. So just watch it. It's, yeah, inspiring maybe, or just to get the idea how he developed it. Sorry. How does it work? So as I've already introduced, the client renders some HTML, which you defined in the UI part. The server then reacts to some client inputs. So the client, in a way, sends the changed inputs. In our case, it was the slider number of bins to the server. And this communication is actually done through WebSockets. So WebSockets is a way how processes, or generally sockets, can be a way how processes communicate with each other. And so for you to know what a Shiny server provides is exactly this kind of course, besides the reactive part, this kind of communication layer between the client and the server. So the client changes the slider input, it sends a WebSocket message to the server. The server then needs to evaluate, okay, do I need to do something or not? If it needs to do something, it just updates. In our case, it was the plot. It sends the plot back to the client. The client knows, based on the ID, where to display the plot, and then just injects it into the HTML. So this kind of thing is just going back and forth the whole time until it reaches a hopefully final state. In other cases, it will then live on its own. But in a case, in most cases, actually, what you want is that it then reaches a final state and then it's done. I can recommend here, if you want to dive a bit deeper, here's a very nice online book, Unleash Shiny, it's called. I just discovered it a few days ago, but I've taken here the plot from them, and for that you get a more in-depth explanation how Shiny actually works. Okay. So do I? Okay. Okay, so this is how Shiny works, and everything is good, and it's already around for a few years, and yeah. Who can complain? It's great. Have created lots of dashboards, made hopefully a few people happy, and yeah. And some of them are still around, actually. Okay, but now we come to a part which is, for everybody who works in a great enterprise, is really the annoying part. So having that kind of Shiny dashboard, which I just showed you before, is quite simple. So if you run it locally and everything works fine, it's great. But when you actually want to use it as a server and want other people to use it, then it can become a huge headache. And this is something where lots of data scientists especially kind of fail if they are lacking the knowledge how to create this kind of infrastructure. But it's not only a technical part, it's also an organizational part. Is the organization ready to actually deploy those kinds of things? Nowadays, it's better and better, but a few years ago, it was only horrible. So in a way, you need to manage this part, how to make your great Shiny dashboard accessible to other users. I'm seeing here. So one way was always to run the Shiny server on a single instance, which is a bare metal instance, maybe, which is within your company or somewhere, which was the classic part of how to deploy Shiny apps, which I honestly wouldn't recommend anymore, unless you really need this kind of bare metal instance and have no other ways to do it. Okay, nowadays, what most people do or should do is they at least encapsulate the Shiny server in a Docker image. Docker is a technology to have is actually a virtual machine to encapsulate a Linux instance in most cases, and in that way you can really encapsulate your entire Shiny setup, including all the packages which are needed for your Shiny server, and can then deploy and run the Docker instance in various, in many setups. So this is once you know which kind of container to use and which kind of infrastructure, is more and more easier. So nowadays I would really recommend that you package your Shiny app in some kind of Docker image. I'm just here missing the link. So a very famous Docker images are from the Rocker family. So this is the Rocker project. It's now called Rocker version 2. I think this is it. Yeah. And this is also on Docker Hub, I think. And maybe I show it on Docker Hub, which is better. Yeah. So this is the guys who developed it. Mostly it was Dirk and Carl, but images. So you have here a bunch of images you can use. I'm typically, so for Shiny, you would use something like Shiny. If you want everything included already, most of the time I'm using R versioned, which gives you a bit more control. But this kind of Shiny, so it would be Rocker Shiny, or maybe it's now Rocker 2 Shiny. This is actually the kind of image you're searching for. So I'm just also adding the link here. So sorry, it was just okay. So Docker would be the first step to make your Shiny app accessible. But of course, you can go further and want to have some scalable infrastructure. So if you have more and more users using your great dashboard, you want your infrastructure to scale up and down and start new instances, and so that your server still is available in case of a heavier load. So I've also, on the blog last year, I posted how to develop this kind of infrastructure, which we've also deployed in various company setups. So we've used here AWS in this case with Fargate, and including everything like authentication, scalability, continuous integration, everything you need to have your Shiny dashboard and also the development pipeline up and running. So it looks like this, but besides the authentication and the load balancer, so what you have is for each dashboard, in a way, a single instance, so a single Docker container, or one instance with many Docker tasks running. And whenever you see that the load is more and more and the CPU and memory usage is too much, you start scaling up and down and start adding more and more instances to this kind of setup. So this is the cloud case. Of course, you can have some kind of on-prem Kubernetes setup, which is more complicated to configure, and which can also do this kind of scaling and increasing instances depending on the load. So it's doable, but this gets now a bit more complicated and involved, and is not something what I would expect from a data scientist, to be honest. But it's possible, of course. The easiest way is, of course, Posit Connect. So Posit has a nice product to just deploy Shiny dashboards or Markdown documents, all those kinds of things. It makes your life way easier. Of course, costs some money, which could be an issue or is no issue in your company, for example. But of course, this then takes away all or most of the infrastructure pain you might encounter. Yeah, so, and regarding deployment, again, depending on your use case, you have to set up the CI/CD pipelines, the Docker containers. You might need some Kubernetes or cloud know-how. You might need to convince IT security, who have, for good or bad reasons, are against your idea of deploying Shiny apps to thousands of, I don't know, users within the company or even external users. In the case of, especially in the case of maybe Posit server, there might be a money issue or a budgeting issue. So all those kinds of things, which are complicated and which might let some Shiny projects die for no good, in my opinion, for no very good reasons. But I've seen that many, many times. Okay, so that's now the status quo. So this is how the world works right now. And now I would like to introduce you to a new technology, a new way of doing things, maybe. And this is here the Shinylive and WebR or Pyodide world. I've written here to the rescue, but to be very honest, still, it's in a very early stage, and I wouldn't recommend it for really the very serious projects, but might already be ready for some pet projects you could start. So what's the deal here? WebAssembly is, as some might know, is a quite new technology, or new, let's say 10 years, might be even longer, not sure, which that WebAssembly has been around and is even standardized in a setup. So that standardized means that all the big browser vendors or browser developers, vendors or products need to implement WebAssembly to be, so that it really functions in a broader sense. And all of the big browsers like Google Chrome, Firefox, Safari, yeah, that's it pretty much, have actually implemented or support WebAssembly. So this is a good thing. If you use WebAssembly, you have a very good chance that it works within every browser, depending, of course, browsers are all different, and in the details, there could be some issues in the details, but they should all support WebAssembly. So WebAssembly, I just also show the link, is a way to compile basically the some existing code. So for example, C++ code, it's also available for Fortran, for example, or others, into a binary, which then in the end, the browser can understand and can execute. So it's actually a compiler framework which allows you to compile existing code in some different languages to exactly this WebAssembly code. Some might even know that, of course, it's using this LLVM toolchain. So it's using this LLVM toolchain, which was actually by, I forgot his name, but he was at Apple, I think, when he developed, oh no, he before Chris Latner, I think. And he is actually the developer of LLVM and Clang, and please write in the comments if that's wrong, just as far as I remember. And okay, and emscripten here is the way to go to compile some code to WebAssembly. And there's even some old games. So if you know Doom, which is some horrible ego shooter, or which I played, of course, a lot, and some other games have all been compiled to WebAssembly and are then, once they're compiled to WebAssembly, available within the browser. So what you can then do is you just open some web page, which then downloads the WebAssembly code, which is the binary, and then executes it. And it's just amazing what works. And especially for 3D games, of course, old 3D games, but it's just amazing that it actually works. So that's emscripten, and that's actually the engine which makes all of these things possible. Okay. And now this is just my interpretation of things and why actually WebR is existing, or what might be might have been the main motivation. So as I've introduced at the beginning, Shiny is now also available in the Python world. So you can create also amazing Shiny dashboards in Python. So, and Python now has something, or a project which is called Pyodide. I'm also just opening the link here. And Pyodide here is a Python distribution for the browser and Node.js based on WebAssembly. What does it mean? They have compiled through emscripten CPython to WebAssembly. And what makes things complicated is, of course, those kinds of languages might also depend on other those kinds of language runtimes might also include other languages. So in the case of CPython, that's not the case. In the case of R, it is. But what you can do then is, once you compile Python to WebAssembly and all of the required packages to WebAssembly, you can actually then execute Python within the browser. So you can have this kind of REPL here. So what you have here, and this is amazing, just but this is now everything running within your browser, because Python and all the other, I don't know if everything is here. Yeah, not sure what happens then. No. Yeah, so you can here import even pandas, which is an important data frame library, and do things in Python, which is great. So you have here an entire Python emulator or Python language within the browser. You can start coding right away, which might be not the nicest thing, but it's great that it works. Okay. So what they did is now, now the story goes like this. Now you have Shiny in Python. You have the Pyodide ecosystem, which allows you to run Python within the browser. So why not run Shiny, the entire Shiny server, also within the browser? And this is called here, or this kind of project is called Shinylive. So what you have here is a nice dashboard, or a few examples here, where you can go through a few different apps. So this is, again, a very simple slider app, which just multiplies the input by 2. Okay, so of course you can change here whatever, my grade slider. You can execute here. So I've just here changed title here. Of course, you cannot only multiply by 2, but also multiply by 3, which I'm doing right now. So 3 times 20 is 60. Great. So this is how you can, even within the browser, develop Shiny apps. So this is a very basic app. Of course, you have apps with plots. So here you have this kind of plot with the number of bins, I guess, which changes the number of bins. Everything within R, and you even have some kind of console, which is what kind of thing is happening here under the hood. And again, and the great thing is, of course, you can also share it. So the editor URL, so everything is then kind of encoded, and you can just copy the URL, send it to some friend, and see exactly the same thing. Or the application URL in this case might be more interesting, and your friend or colleague then receive this kind of huge link, but gets exactly the app he, she wants. And this is now the app which has been shared. And the beautiful thing here is it's just encoded through the URL, the entire app, and there's no other infrastructure running behind. So this is like JS Fiddle, and it scales, I don't know, indefinitely. So that's a great thing to have, and runs everything within the browser. Just to make sure that it really runs within the browser, let's see what is happening here. You have some sources here. And what you should see is exactly this kind of Shinylive service worker, and also the Pyodide worker. So this thing works, everything works within the browser using a worker, a JavaScript work process, so which is running Python, and also a service worker, which is communicating between the client here and the server here. The client here and the server beneath. So this is not shown here, but this is basically the server here. And everything is within the browser instance. So there's no deployment of Shiny anymore, no Docker, no... of course, you can have some CI/CD pipeline, but you don't need to run a server behind the scenes, or physically run a server, which is a great thing, or which is just for me very exciting, and which I've never thought could be realized. So let's put it like this. Okay, so this is Shinylive running within Python. I'm just showing you, there's few examples here. Everything here is using the Shiny Python package. You have plotly plots, of course, all kinds of things. So many things are possible for your Shiny apps, even within the browser. And yeah, it might be a very great fit just to try things out, show it to your colleagues without running, you know, some more complicated thing. This is an interactive plotly plot. Yeah. Okay, so this is how things work within Shinylive. And now my story is, I think that the R, or this is in R and in the R and Python community was always the case. was the case for many, many packages. Pandas was an inspiration from data frames. And here I think that the R community or people from POSIT just got interested and thought, okay, now this is working in Python. So why not try it for R? So why not run R within the browser? Because R, as you might know, is also based on C and some Fortran. But why isn't it possible, or why couldn't we use R also within the browser? And this is exactly this kind of chain of thought, I think, is the inspiration for WebR. And so WebR would be then, just for you, is the equivalent to Pyodide, just in the R world. And lots of people asked about this and tried it. And Joe Chen even, or the developer of Shiny, even thought for a very long time, and myself included, that this doesn't work at all. It's just a stupid idea and way too complicated, and why? But they've already announced, and you can already see that it's working. And this is WebR. So WebR is a project by George Stagg. He's an employee from our studio. He was the initial creator also of WebR. You can also check it on GitHub. So that's George. And yeah, he and his colleagues did the hard parts of trying to compile R for the browser through the Emscripten framework. And you also see it here in the project, what you need to build WebR from source, which basically means, okay, you need to build R through Emscripten. So it's just kind of involved. You don't need to know this, but just if you want to dive a bit deeper, just that was the pointer. Yeah, and then you see that they've done the hard part of compiling R and depending packages via Emscripten, so that everything, the entire language runtime, including the packages, because R without packages is not worth it, is available within the browser. And you see here that they've even created a repository. I'm sorry, it was the wrong one. I'm not sure where. So they've developed an NPM package to use R from JavaScript. So to talk to R within a JavaScript environment, like from JavaScript to TypeScript. So there's an NPM package available, which allows you to instantiate an R instance. And as I said, they also compiled all those kinds of different packages. I'm just not, yeah, we're coming to that later. So they did the hard part. Nobody else has to do it anymore. And that's great. And as a first, what you can show here as a first example is this kind of WebR, this kind of interface. So this is, you can also call it RStudio for the poor. But what you can do, for example, is execute code, like the bloody empty cars data set, which you can run, which you can show here, which you can, for example, where you can build models around it. So where you can build, for example, where you can, for example, build a linear model around it. Where you can, so this is just for all of you who know R, just working. Of course, you can also plot things or use, so for example, you can plot empty cars weight against empty cars MPG. So the weight of the cars against the miles per gallon. So the heavier the car, the less miles it goes per gallon. So the more fuel it takes. So that's just this kind of relationship. And interesting, you can also, of course, use other libraries. In this case, it would be ggplot2. Let's see what happens if I'm loading a library. Here, it just complains, okay, failed to load package ggplot2. Do you want to try downloading it from the WebR binary repository? Of course, yes, please. Now it's downloading all the packages. So everything is now loaded within the browser. So the instance which is running within the browser has now loaded all the packages. And then, of course, I can just use it. So empty cars. And we have a geom point with weight and MPG. And we just, okay. We need to load the library and do that. And now you see, okay, now we have a ggplot here. Of course, yeah, just add a geom smooth here. For that, I think I need to put this up. Yeah. Something like that. Okay. So now you have exactly the same plot with ggplot2. It has all been loaded dynamically. And you see also here some file systems. So you have some virtual file system within the browser. So everything you see here, this kind of development interface is all running within the browser, which is, I think, kind of astonishing. So this is actually running locally on my machine. And if you just check the developer tools, you see that here we have all this WebAssembly running, and everything here, all the assets which are used to run this app are actually locally available. So have been downloaded and are running locally through this kind of web worker. And this is kind of astonishing, which is, it still gives me a huge wow. And yeah, it just works. I would suggest to take a quick biological break for 5 minutes. And I will be back in 5 minutes, 5 after 10. Please, if you have already collected some questions or have any questions, please let me know and put them into the Q&A or shout out loud, I don't know. So we take a 5-minute break and then we come to the most interesting part, which is how to develop your apps or how to develop your Shiny apps on your own, which then also use WebAssembly and run without a server. So please stay tuned and I'll be back in 5 minutes. Hello, I'm back. I hope the break wasn't too short, but yeah, let's continue for the final run. Nico just asked that how about connecting Shiny to databases such as Elasticsearch, TSQL, PostgreSQL, in such scenarios that you presented, Docker, POSIT Connect, browser, WebAssembly. So, Nico, yes, via Docker and POSIT Connect, you can easily connect Shiny to databases. So I've done this in various scenarios, especially for what you've mentioned, PostgreSQL, but also MongoDB and others. So there's actually no trick as such. The only thing is that if you run within a Docker container, you just need to ensure that the Docker container or your infrastructure has a physical network connection or has a network connection to the database. Maybe you need to open some ports, but that's not such a big issue. So one thing is always the connection, and the other is that sometimes it can be, sometimes it can be hard to use the right authentication scheme. So the question is always how to ingest the required database authentication, how to manage usernames and passwords. Do you have single sign-on or not? Or do you have some other authentication scheme? And this is something a bit harder or might be harder. So the easiest way is typically to have the passwords within some kind of system variables, which you basically have running within the Docker container, which runs the Shiny app. So this is easy. If you need to have, for IT security reasons, some other schemes like single sign-on, or that you really want to ensure that the end user who connects to the Shiny app also can connect to the server using the same credentials from some kind of authentication provider, then it might get a bit harder, but not impossible. But those kinds of schemes might not work directly with a database, but maybe through some kind of API. So this is for sure possible. But the question was actually, how does it work also within WebAssembly? So for those kinds of apps, as you've seen, okay, I can even download some additional packages, which is of course also externally through HTTP. But to be honest, I haven't tried connecting to those to the databases you've mentioned within WebAssembly yet. I'm pretty sure that it should work, but I haven't tried, to be honest, and would be happy to hear maybe your feedback. But the question I've already said is, in a more professional setup, question is always how to incorporate those kinds of secrets. Because if you have those secrets just lying openly around or within your browser instance, everybody can read through it, and can even then connect to the database. So this is a huge security issue which you need to solve before you actually have let these people access to the database. So that's actually the reason why I haven't tried it yet in a more serious way. But connection-wise, I can imagine that it should work, if not directly, then still through an API. But I know that this might be a big the biggest issue actually to really connect to some kind of maybe even enterprise set database. Because in that kind of setup, since it's all running also within the client, every client needs to have access to that kind of database, but still might or still shouldn't have access to the credentials. So this is kind of weird security-wise, but it should be doable. So I know from other frameworks which use WebAssembly and have database connections. So technically it should be possible, but currently I'm not sure if this is true and should be tested. Okay, I hope that answered your question in just a bit. And I'm just now continuing with the content. So as you've seen here that you can run everything here within the browser, which is great. But how can we go further? At the very beginning of the tech tutorial, I've introduced you a bit of how, or roughly how it works under the hood, how a Shiny server, how the client communicates with the server. And it's doing this, the communication is actually through WebSockets. So the client communicates through the server with WebSockets. And now the question is, once we now want to run a Shiny server within the browser, how can it be done to that everything, the client and the server, actually run within the browser? And this is done in two ways. One is that, and actually the key to this is since the new release of WebR and through that HTTP UV package, which is also working under the hood of each Shiny server, that you need this kind of package that acts as a proxy between your WebR worker, which is actually running the R session of the whole thing, and also the JavaScript worker, service worker, which is dealing with the communication between client and server. So in a way, you need this kind of proxy server, which then proxies the communication between client and server, not to some different, or physically some different machine or different server or different instance, but actually it should proxy all of those requests within the browser instance. And this is actually the key part here, which is done by this HTTP UV shim package, which is proxying the communication between server and client within the entire browser instance. And this is the key part here. And this is why it's actually possible to run not only R within the browser, but run Shiny within the browser, because of exactly this package and because of the proxy between those parts. And now maybe I'm jumping now to an example repo, how things could work or how things work, just to give you a bit more detailed overview of the most important pieces. And this repo here is by George Stack, who I introduced, and it's the Shiny standalone WebR demo. So I'm just clicking here, showing you this kind of repo. You can just clone it, use it, and I'm just showing off here how I was showing here what this package is doing. So here I've already, okay, this is basically the checkout or the cloned package here from that repo. And Now I want to introduce you to the most important parts. So of course, the index HTML, the Shiny.js, and the HTTP UV service worker. So the index, so what we have here within that repo is exactly the index, the Shiny.js, and the service worker.js. So those kinds of JavaScript files. For all of you who don't know JavaScript, you don't have to care. You just can listen to something else. And I will come back to maybe, hopefully, next section for you more interesting parts. What you have here is also the UI. So that's, of course, again, our standard Shiny UI and server parts. Everything is our code, all good. Now I want to introduce you what is happening actually here under the hood. So we have here the index HTML, and the index HTML is basically doing nothing else than loading the Shiny.js. So index HTML is loading Shiny.js. Okay, nothing else. So the Shiny.js on the other side, or which is then loaded by index, is doing a bunch of things now. It's, for one thing, is registering the HTTP UV service worker. So this service worker is required for Shiny to work, so that this service worker acts as a proxy between client and server, what I've mentioned before. Okay, so it's initializing the service worker here. And then it's doing a few other things. But most importantly, it's initializing WebR. So here it's initializing the R instance within the browser. Okay. And once this is okay, it's now going to fetch. I'm just highlighting this here. It's now fetching exactly those files which are actually here in the same directory here to the so-called virtual file system. So you can imagine, just imagine the browser itself has a virtual file system. And before we can even execute those files, we need, for Shiny in this case, we need to fetch them to the virtual file system. So the app UI file here is being copied over or fetched into the browser's virtual file system. So this is important, so that we have the files locally within the virtual file system. Okay. And sorry, I've jumped a bit. And this is now the important part. This is now actually WebR write console. This is now actually running the app. So this is now changing the library paths so that everything can be loaded within a different directory. All the packages is loading the Shiny package, and it's running the app. So this is actually what Shiny.js is doing. Shiny.js is really the workhorse here, which is initializing the service worker and copying over the files and loading the app. Everything, again, everything within the browser. There's no browser running. Sorry, there's no external server running. So this is the key parts here. Okay, now, of course, there's an index HTML. What we could do, of course, is we just open it in the browser. Loading WebR. As you might see here, this takes a while. And as you see on the messages here, it doesn't work. It doesn't work because it failed to register the service worker, because the URL protocol of the current origin, null, blah, blah, is not supported. Okay, so you cannot just open the index HTML and everything is fine. The problem here is that it really needs to be served. It needs to run within the server context, so-called server context. So it needs to run through a web server. So what you could do, okay, simplest approach would be there's a nice library called package called, there are hundreds of ways to run a stupid web server, but here I'm just using servar, and I'm just using httd static, and yeah, it's just a current directory. So I'm just serving now the index HTML. Yeah. Okay. And it's served here. As you see here, it's running here this kind of local server through the loopback address. And you see here exactly our Shiny application. So the Shiny application we had here, or we had before, is now running everything within the browser. So as you see here, it's working. So all good. And I've lost my instance again. I think this is it. Yeah. Okay. So as I've said, if I now change the app here, for example, and for example, in the server case, I'm getting bored of those kind of stupid, sorry for the language, but if I'm bored of this kind of simple histogram, and I'm using now a ggplot here to, instead of using a base R histogram, I'm using a, for example, ggplot histogram with the faithful data, and we use a geom histogram instead, and with weighting here, and the bins, of course, we use directly here for input bins. So instead of this histogram, we're using this histogram. Okay. And we're using now also a different library here, an external library. Then what really it is doing is it's now rendering the whole thing again. Oh, maybe I forgot something. Okay, that's not working. It could also be a typo or something. Not sure. Let's check it locally. Okay, that works. Or does it? Yes. Okay. Okay, let's see again if it works in the server context. Arrows. Okay, for some reason it doesn't work, but it did, I promise. Okay, I'll just move on, but I just want to, maybe I just go back here. It should have been the proof that actually what you see here is really the app I'm editing here. Okay, also doesn't work. Very strange. Okay, maybe something else is going on. But yeah, this should work. And just, you have to believe me, the app files which are here are really loaded within the browser instance. So this is all good. Of course, it all depends on those kinds of files, but if you have most of your, or if the packages are available through WebR, it should be doable to run your Shiny app within the browser. So this is one key message here. And why I've used this kind of standalone demo is really to give you a hint of what are the most important parts in this kind of setup. But of course, there's different ways of how to do that. I'm still running the same server here. Maybe I'm undoing it. Now it should work, right? Yeah, maybe this serve R is not the best way to do things. Okay, now it works also for, okay, now that's the basic histogram. Okay, so this works, but it didn't work with the ggplot2. Okay. Okay, but for your, let's say, more production setup, I would recommend actually not to use this kind of standalone demo, but the way to go would be the Shinylive package. So there's this Shinylive package available, which allows you to, okay, to basically export your existing app here. So app to a new directory. And this directory I called, I'm just deleting it here, but this directory I called site. So what's happening here? It's Shinylive will take your existing Shiny app. And of course, if you have in your Shiny app some other packages around, or different packages around, or different, let's say, yeah, or another set, or an RN for an RN package dependency file around, it will detect your dependency packages and also then load them live into the thing. But if I'm now using this kind of Shiny export, use my existing app and copy it to a new directory, then it should now create a new directory called site. And this site now contains, again, the index.html, the service worker, and of course, now it's called app.json. The app.json is something else, I think. Yeah, but it's now containing all the assets which are required to run your application within the browser. And this can be done through Plumber, for example. Also, Plumber here is the recommended way to run your app. For some reason, it tries to serve here the docs folder, which is not available. So I'm just using here the base folder here. And this takes a while. Why does it take so long? And the answer here is the developer tools. So it's downloading now all of the dependencies required to serve the app. So it has loaded WebAssembly, and during the page load, it now starts to install all of the required packages and serves it. So everything, again, happening within the browser. And now you see, okay, the app is working. Great. It seems okay. Now we can go further. Actually, what I did before is what happens if, you know, I've deleted, of course, but what happens if I'm now using a different package here and I'm full, and I'm showing a histogram with the number of bins input bins. Yeah. Okay. So what happens if I'm now just exchanging the base R plot with the ggplot? I'm exporting, or I'm stopping here. I'm exporting again. Yeah. And I'm running everything through Plumber again. Okay, again, this takes a while. Might be more interesting to actually see what it's doing. So here we see that a bunch of packages are being installed, and hopefully also the ggplot2 package will be installed, which is now required for our plot. Okay, now you see that the last package was ggplot2. Great, so this should be available, and we have our ggplot. So now we see that this should be working. It's slower than expected, but it actually works. So you see here that everything is here. And this is kind of the development loop. You can go and see, okay, once the app is running and hopefully all the packages are available through WebR, then it should be possible to run your app within the browser. That's great. However, as you saw here, all of the packages you need are being installed on the fly during the first load. And this is, I guess, or in my opinion, the biggest problem here, that the first load time is so slow. But we'll come to that in a minute. Okay, so this is how you can further develop your Shiny app, and it even detects what kind of packages you've used. And I've lost my presentation. It should be here. Yes. Okay, so this was now just a short demo how to use Shinylive to deploy your site within the browser. Or if you don't want to have it in the browser, and this is actually the good part, which I've not mentioned now, this site directory you just copy it to some S3, to some very simple web server, which doesn't need any management, which is so standard that it's just, yeah, you just need to copy it over and it just works. Of course, the first load time is slow, but you don't have to manage any server here or any complicated server infrastructure. It just works, it just scales, it's just running on the client side, which is great. Okay, but now not everything is great yet. We have a few problems, and this is just a big disclaimer. If you already start shutting on DA and want to start doing things with Shinylive. Of course, one thing is the long loading time. So the loading time so what happens during the loading time, WebAssembly is being loaded and the packages are being installed on the fly. In my opinion, so this loading time can be shortened if you manage to put together your package library of WebAssembly packages and just copy that kind of library over to the virtual file system. So this would be one approach. Of course, it is still a bit involving, but it could work. That, or at least it could be faster than this. In my opinion, the best approach would be to have some kind of WebAssembly with an R instance and all the packages required already included, in my opinion. But so far, the second best approach currently is to put together your WebAssembly packages which are required and put them somewhere in your project. And then at the initialization, you don't start downloading all the packages, but instead are copying over the package library. So second, package availability. Not all packages from CRAN or from elsewhere are available for WebR. And the prerequisite to use a package is to actually have this package compiled for WebR. So without that, this whole magic doesn't work. And you see here on the link, just opening it, it is of course also another Shiny WebR application. So it's loading here on the fly the package list, and it's doing a bunch of things. And this list gives you a hint what packages are available and what are not. And currently, I think there's about half of the packages are available. And the main reason why some other packages are not is, or the half of the packages, close to half the packages are not, is that some small dependencies are missing. So you see here R has, I thought it's over 20,000. Again, it has about 20,000 packages and only 10,000 are available. So in the case of Abacus, for example, it's not available, and it's not available because a bunch of those things, of those packages are not available. Most probably because they depend on some external library which couldn't be compiled to WebAssembly. So that's the current state. It's not too bad, but it's also not great. So what we've used here, ggplot2, for example, as we've seen here, is available. dplyr, so if you're more into the tidyverse, is available. Plotly, I think, is not available. I thought it is, because curl is missing. Yeah, so you have to dig through that kind of list and see if for your project it makes sense and all the packages are available. Otherwise, this doesn't work. Okay. So package availability, again, it can be a pain. Okay, problem 3, custom packages. So all of the packages within WebR need to be compiled, as I've already introduced. If you have some custom package you developed and want to use within WebR, it also needs to be compiled. And thankfully, there's some CI/CD pipelines, some example pipelines available, which show you how to compile your custom package to WebR. So I've also put the link here. So this is just some GitHub actions in that case. How the package can be compiled to WebR. Okay. Okay, and that was it for now. Of course, nothing is set in stone, and everything I've just presented here is still lots of moving parts around, lots of balls in the air. But what you already see is that this kind of approach is working. WebR is working. You can even execute or serve Shiny dashboards within the browser, which is amazing. And I haven't believed that this is actually working at all. I think that this kind of approach will, in a way, be maybe the second best guess to deploy Shiny apps. For some use cases, might be even the best way to deploy apps. No other infrastructure required, no other headaches. So every developer should be able to, I think in the future, to deploy a simple app and put it out there, and it just costs next to nothing. And that's really great. So for the whole Shiny ecosystem and generally for the R and Python community. Maybe it's bad for cloud providers, but they also already earn lots of money. So it's also better for the environment, of course. You don't have to run some instance which waits the whole time just for some user to come around. So yeah, there are many ways to argue for this kind of approach, but of course it has some downsides currently, and but those kinds of downsides might improve in the future. And if you want your last argument, or which might be annoying for Shiny users who just go for a coffee or for lunch and come back, that they see something like this, disconnected from server. And this is the thing you won't see anymore if you use those kinds of WebAssembly dashboards. So I thank you for your attention. I hope you enjoyed it a bit, learned a bit more about this kind of new cool, I think, technology. Just let me know in the Q&A if you have any more questions. So I'm happy to answer right away. If you have any other questions which are about some other topic, data science related, project related, or some issues you encountered, please let me know. I'm around in Belgrade from tomorrow onwards. Just contact me, for example, over LinkedIn or emails. So I'm happy to answer your questions and connect to you. And yeah, last but not least, and again, a very boring advertisement is for the USAR conference, which is taking place in Austria, yay, in Salzburg, not Vienna, but still. And I would also be happy to, maybe we see each other there in July. It's the biggest R conference around, and yeah, I'm already very excited about this. But in any case, let's enjoy the data science conference in Belgrade. So I'm already wearing my t-shirt. I'm happy to see you all there. It's always a great experience. And just let me know if you have any more questions. I'm not seeing any of the questions in the Q&A right now. Maybe I'm wrong, but yeah. If you don't have any more, I'm saying thank you and see you all this week. And yeah, happy to connect to you.
Thank you, Mario. It was very interesting. And thank you everyone for watching the tutorial. Goodbye.